Hello, Googly friends. My name is Jonathan Cervelli, and I'm here to talk to you about Splunk. So what is Splunk? Well, we are most famously known as a t-shirt company, but less well known for the fact that we are the biggest name in big data and turning data into doing. So we're going to spend just a couple of minutes going into how Splunk can use data to help solve some of your cloud problems. So let's get right into it. So first of all, I would like to start all relationships with a note from my mother. She likes to remind me that I don't always get what I want, and my future predictions don't always come true. See also selling Dogecoin. Bad idea. So you should take everything I say when I talk about future things with a grain of salt. But hopefully we won't talk about the future too much. We want to talk about what we can do for you today. And so to wit, let me tell you something that you probably already know, which is that, wow, things have gone digital real fast, especially as we all mostly have been working from home or having to be out and about in areas and ways that were a little bit different than they might have been a year ago. And this has driven a lot of things into the cloud and a lot of things digital. And so now for the first time, the majority of interaction with customers and stakeholders is actually happening digitally. Well, you're probably in IT, so you probably were already doing that, but it's still kind of shocking to realize just how fast this change has happened over the last year. We all kind of knew it, but as you can see here from the data, it's pretty remarkable in terms of how much more we are relying on the internet, how much more we're relying on cloud services, and how much more we're relying on digital interactions for pretty much every part of our life, from government to purchasing to ordering a taco. And so that has created a lot of pressure for organizations, especially some organizations that perhaps weren't totally on the digital bandwagon, to move and move quickly. And that has created a lot of opportunity and a lot of challenges. What do we mean by that? Well, here's the funny thing. If you're not one of the, $12 latte sipping cool kids, and if you are, cool, I'll take one too. But if you're not, and you didn't have the opportunity to rebuild everything in a truly cloud native architecture, you're probably working with a lot of, I won't call it legacy, we'll call it foundational technology that might span back longer than we've been alive. And that's true in a lot of organizations. And while everyone is frantically trying to lift and shift and refactor things to make them more dynamic and more cloud friendly, the reality is it's not going to happen overnight. And the further reality is if you're like a lot of companies, you probably just can't up and do that, at least not right away. And so the challenge that we have is, well, we're building all these cool new data digital experiences, like on my mobile device, my smartwatch, talking to my TV. All of those things have an ever longer service delivery line that might go all the way back from a super cool GCP Kubernetes controlled API-centric microservices, ... to a mainframe and everything in between. And all those APIs, one of them might be a 3-tier architecture based on Java. Another one might be true microservices. And make it more fun, because it wasn't fun enough, what if we throw our suppliers and partners in the mix, like a payment provider, or people putting advertising, or trying to put other content in our shared content. And now we're dependent on them to also deliver our outcome to our stakeholders, customers, employees, et cetera. And so you get this very long service chain, not all of which is under your control, but that you're accountable for. And that's naturally pretty hard. And so a lot of organizations are trying to struggle because while they have great point solutions for each one of these, there's some awesome products on the market, there's no real way to get a unified view across these. There's no common language that the people who are, the DevOps people running microservices can talk to the people running the 3-tier architecture that own the API set they need. How do you get these people to get a single unified way of thinking about service delivery, stakeholder outcomes, and the overall quality of your data? Surprise from the data company, we think the answer is data. Making data an essential service. And whether or not that is data that you need in order to run things better, data you need in order to secure and see what the bad guys are doing, or gals, or figuring out how you can take your data and turn it into an asset, whether it's doing better for your customers, stakeholders, or whether or not it's actually itself even something that you can profit on and sell from. Maybe they're unique things that you know based on what you do that other people might want to know. and you can provide that as a unique service. But one thing I do think is generally accepted is that data is pretty much going to be the, as they say, oil of the next generation. Organizations that master it will exceed. Those that don't will probably cease to exist. Might be a little bit melodramatic, but they're not going to do very well. And obviously we are currently at a conference for a company that exists primarily because they believe in the value of data. So hopefully you do too. But now that doesn't mean that this was easy. If it was easy, you would have already done it. Maybe you already have in pockets. But the challenges are we still have all these data silos. Data doesn't like to talk to each other. It kind of has structures that are not always consistent or easy and kind of messy. And you might very well, thanks to procurement, have a multi-vendor strategy. Multi-vendor means you can't have a single tool chain. So while it looks cheaper on paper, it might end up being much more of a human cost than perhaps everyone wants to admit. So how do we get all this information into one unified place? How do we wrangle all of this data? Well, provocatively, about a little while ago, Splunk decided we're just going to take traditional data science, the relational world of data, and throw it out like last week's salad. We just said, nah, you know what? We're not going to structure the data. We're just going to pour it into big buckets. Because data, well, it says unstructured on this slide. I'm not a big fan of that word. It's really polystructured. It has a structure. It just has its own unique structure. And you probably have thousands of things with their own unique structure. And it would be sort of a fool's errand, or at least incredibly intensive, to try to figure out how to get all that data neat and nice and organized. So don't do it. So Splunk just said, forget it. We're going to throw it in a big bucket. On top of that bucket, we build an index. That index is just like an encyclopedic index. In other words, if you were to look up Jonathan, you would find everyone named Jonathan and all the things that Jonathan had done. And you could begin correlating all the places I have been to, even if maybe Jonathan, the word, doesn't actually appear. So that index is actually really quite powerful. You can almost think about it with this investigative approach, like going down the Wikipedia hole. You can find one thing and it leads you to another and to another and to another. And pretty soon you're able to diagnose very, very complex and difficult challenges, track down what bad people are doing, or more deeply understand the needs of your customer. So once we take all this data, and the first step is making it really easy to collect large amounts of data, then the next thing we do is we do all of the work of normalization and adding structure at query time. So we just take a big pile of schemas. We don't know what they are. Maybe you give us 10 data sources. Maybe you give us 1,000 data sources. We don't know. Don't really care. What we do is for each one, we will build a schema. If there's a convenient one there, we'll use it. If not, just like your Miranda rights, if you don't have a schema, one will be made for you using machine learning and text inference. And so now we take and we jam all that together and we make a table for you. And so even if there might have been dozens of different schemas, we didn't know what they were, this just bakes the brain of BI people out there, I can tell. We just jam it all together in a big union, and then we make a really useful table out of it. And then through the power of our search language and some machine learning, we boil it down and we go from what might be a big pile of noisy data to something that looks more like a G sheet on the other side, a nice, relatively neat table. And we do that despite the fact that the data that went in was perhaps polystructured, messy, inconsistent, and we help you get over that challenge. And a great example of that, since we're talking cloudy stuff, one application of doing that is let's combine 3 totally different types of data: metrics, like numbers; traces, which are where things have gone, using, in our case, open telemetry, one of the biggest supporters of CNF, and also, and make it so that we don't have to do any kind of reduction of that data. So you take the logs and the traces and the metrics, full fidelity, no sampling, at any scale, and throw them together into our data platform and let you see exactly how your complex next generation web stack might be doing. This is just one application of the Splunk platform, but a really powerful one, and probably, if you're watching this, relatively relevant to your interests. And here is my ghetto demo of showing you how we can go from infrastructure to traces, and then look directly at logs, and bring it all together into a single unified view with one consistent workflow that really empowers DevOps teams or DevSecOps teams to get true full visibility in terms of what is actually happening with these complex microservice infrastructures, which, as you know, we continue to make more and more complex, and eventually so complex it's very hard for the little human brains to possibly understand it, which is why we need machines to help us do it. And this is an example of one of the applications of being able to take all that polystructured data, throw it into buckets, and then make meaning out of it automatically for you. And so this is one use case of many on Splunk, but it's one that we think is particularly powerful and probably of interest to this audience. And so now I'm going to use the rest of my time to not talk about us, because that's boring. We're a vendor. You probably don't believe me anyway. Okay, I don't blame you. But let's talk about customers, real customers, what people are actually doing. So here's an example. If you've ever had if you ever popped a tire or ran out of gas in the United States, you might have called these people. They are AAA. It's a parent organization that sits on top of all your local AAA clubs. And what they needed to do is they needed to have, because they have so many different sub-agencies and so many different subsidiaries and so many different service partners. After all, they don't own the tow trucks. They also provide payment services. They provide insurance. They're a very multifaceted organization. So they have a lot of people in the supply chain for their customers. And so they naturally needed to have a multi-cloud, and they had obviously lots and lots of foundational technology, but we're moving very, very quickly to try to modernize, because after all, their customers and their other stakeholders are probably anywhere but in an office. And so one of the things that we were able to do with them is make them very successful moving workloads into GCP. How do we do that? Well, in large part, it's because we let them compare workloads they were in before with workloads they had moved to make sure they were getting the same performance, they had the same security posture, and that they were getting the same outcomes they could measure not only from their internal view, but from their customer's perspective as well. And that helps give them a confidence in making a move to cloud that would have otherwise been difficult, or would have been kind of a leap of faith. And we think data is better than making leaps of faith when it comes to trying to service people who are stuck on the side of the road. So with that, I want to thank you for your time. That was a super brief introduction to what Splunk is and what we do. I do hope that we see more of you again. You're always welcome to come to our website for any further questions, more information, or perhaps a very nice shirt. Thank you, and have a great rest of your day.